The 737 airplane has 3 fuel tanks. Main tank number 1 and number 2 are in the wings. Each tank has a usable fuel capacity of 8,630 pounds. Most of the center tank is in the fuselage. The center tank usable fuel capacity is 28,803 pounds. The airplane has an external fueling station in the right wing. Each main tank uses 2 electrical pumps, one forward and one aft. The center tank has a left fuel boost pump and a right fuel boost pump. The main tank number 1 and the left center fuel pump supply fuel to engine number 1. The main tank number 2 and the right center fuel pump supply fuel to engine number 2. The cross-feed valve lets the main fuel tanks supply fuel to the opposite engines. The check valves make sure the fuel flows in the correct direction. This prevents the movement of fuel into the tanks. The center tank fuel pumps have a higher output pressure than the main tank fuel pumps. Thus, the center tank fuel is used before the main tank fuel. An engine fuel shutoff valve and a spar fuel shutoff valve are in each fuel line to the engine and are electrically operated. The spar fuel shutoff valve is electrically controlled directly by the engine start lever. While the engine fuel shutoff valve is electrically controlled through the electronic engine control. The engine fire warning switch electrically controls the 2 valves. A mechanical engine-driven fuel pump supplies suction fuel feed when there are no fuel pumps to supply pressurized fuel to the engines. In this example, the 2 main tank number 1 fuel pumps have failed and there is no fuel in the center tank. The mechanical engine-driven fuel pump moves fuel through a bypass valve in each main tank. There is no bypass valve in the center tank. The fuel control panel is on the forward overhead panel. The fuel pump switches operate the fuel pumps. Now turn on the right center tank fuel pump. The right center fuel pump now supplies fuel to the right side of the fuel system. A low pressure light for the right center fuel pump illuminates when the output pressure is low and the related fuel pump switch is in the on position. The light extinguishes when the pressure is normal or the switch is in the off position. Turn on the left center tank fuel pump and look at the indicator. Turn on the two fuel pumps for main tank number 1. The low pressure light for a main tank fuel pump illuminates when the output pressure is low or the switch is in the off position. The light extinguishes when the output pressure is normal and the switch is in the on position. Turn on the two fuel pumps for main tank number 2 and look at the indications. The cross-feed selector controls the cross-feed valve. The selector is in the closed position and the related valve open light is extinguished. Open the cross-feed valve and look at the indications. When you turn the selector to open, the valve open light illuminates bright. It shows the cross-feed valve is in transit or not in the commanded position. The light illuminates dim when the valve is open. When the cross-feed valve is open, the right and left sides of the fuel system are connected. Now close the cross-feed valve and look at the indications. The fuel system is now in a typical pre-flight configuration. The engine valve and spar valve closed lights show the positions of their related fuel shutoff valves. When the valves are in the closed position, the lights illuminate dim. The lights illuminate bright when the valves are in transit or not in their commanded position. The lights extinguish when the valves are open. The fuel temperature indicator shows the fuel temperature in main fuel tank number 1. The maximum permitted fuel temperature is 49 degrees Celsius. The minimum permitted fuel temperature is the higher of two values, minus 45 degrees Celsius, or the fuel freeze value plus 3 degrees Celsius. The filter bypass light illuminates to show there is an impending filter bypass because the filter is contaminated. Fuel quantity indicators are on the upper display unit. The fuel quantity indicator shows the usable fuel in each tank. Touch any control or indicator to review its function. For pre-flight, you set the fuel control panel for engine start. First, make sure the engine valve and spar valve closed lights are illuminated dim, and the filter bypass lights are extinguished. Close the cross-feed valve. Make sure the valve open light is extinguished. And the total fuel quantity matches dispatch requirements. Now turn on the fuel pumps for the tanks that contain fuel. Make sure the low pressure lights are extinguished. The fuel control panel is now set for engine start. We now discuss fuel management for normal flight operations. Fuel must be balanced for taxi, takeoff, cruise, and landing. The two main fuel tanks must be full if the center fuel tank has more than 998 pounds of fuel. The maximum permitted difference in fuel quantities between the main tanks is 998 pounds. If the difference is more than 998 pounds, an amber imbalance alert is shown on the indicator with the lower fuel quantity. For normal ground operations, the APU uses suction to get fuel from main fuel tank number 1. But extended APU operations can cause a fuel imbalance. If extended APU operations are required, fuel from the center tank is used to prevent an imbalance. Turn on the left center tank fuel pump. Now the APU gets fuel from the center tank. The flight is completed and the airplane is at the gate. After engine shutdown, turn off all the fuel pumps. Let's now look at some non-normal conditions related to the fuel system. There are 3 non-normal conditions that relate to fuel quantity. They are fuel configuration, fuel imbalance, and low fuel. With these conditions, an amber alert shows on the affected indicator and the digits and arc color change to amber. In this example, there is a fuel imbalance. A fuel configuration alert is shown on the center tank if the fuel quantity in the center tank is greater than 1,600 pounds, at least one engine is running, and the 2 center tank pumps are off or have low pressure. In this example, the center tank pumps are off. The alert is inhibited when the center tank fuel quantity is less than 800 pounds. If there is a fuel quantity difference in fuel quantity between the main tanks of more than 1,000 pounds, a fuel imbalance alert is shown on the indicator with the lower fuel quantity. The alert extinguishes when the imbalance is less than 200 pounds. A fuel low alert is shown when the fuel quantity in a main tank is less than 2,000 pounds. The fuel low alert inhibits the fuel imbalance alert when the two conditions exist. The alert extinguishes when the fuel quantity is more than 2,500 pounds. Here is a review of the fuel quantity alerts. Now let's correct an in-flight fuel imbalance. The first example is an in-flight fuel imbalance with fuel in the center tank. To correct this imbalance, first turn off the two center tank fuel pumps. Now open the cross-feed valve. Next, turn off the fuel pump. Engine number 2 now gets its fuel from main tank number 1. Monitor the fuel quantity indicators until the fuel is balanced. When the fuel is balanced, turn on the main tank fuel pumps. Turn on the center tank fuel pumps. Close the cross-feed valve. Continue to monitor the fuel quantity indicators and keep the fuel balanced. This example shows fuel imbalance with the center tank empty. To correct this imbalance, use the same steps as before, but it is not necessary to turn off the center tank fuel pumps. The last non-normal condition is related to the quality of the fuel. If the fuel filter has contamination and there is an impending fuel bypass, the filter bypass light illuminates. The fuel system annunciator and master caution lights illuminate. Reset the master caution system. Degraded engine operation can occur when the filter bypass light is illuminated.